Let's get this started. So this is the third session of Protocol Symposium, where we talk about protocol design, like trade-offs around it, ideas around it, and so on. And thanks everyone for joining. I can already identify some people that join all the sessions. Perfect. Today we have Lily. Lily is a software engineer at Astria Labs, where they build shared sequencing and sequencing tools. And before that, she was a TLDR research fellow, and she has done security auditing, smart contract security auditing in the blockchain space for a long time as well. Thanks, Lily, for joining, and the floor is yours.
Awesome. Thank you, Mohammed and Dom, for hosting this symposium. I think it's a very cool space for people to share ideas. And yeah, today, my name is Lily Johnson, and I'll be talking about app-specific sequencing infrastructure trade-offs. As Mohammed mentioned, I'm a core dev and researcher at Astria. You can find me on Twitter at Lobster Mindset, or if you're like old school, I have email at lily@astria.org. And yeah, today I'm going to be talking to y'all about like app sequencing trade-offs. I've been thinking about this topic since last October, so not too long. So I feel like this is like a newer topic space that our community is just becoming aware of. Application-specific sequencing, I think it's like having its like time on crypto Twitter right now, just in terms of like VCs are talking about it, like there's companies being built to explore it, and then like some of us researchers are just having fun writing blog posts about it. And I think it's such a hot topic right now is just because the crypto community is becoming aware that applications that are unable to sequence themselves end up leaking a lot of value. For example, with the high volatility in the Ethereum like ecosystem the last week, with just like a larger market movements, like a single builder, their blocks were able to capture about like $3 million worth of ETH of leaked application value. So like the main reason why we want to talk about like application specific sequencing is because it's a way for like applications to, instead of like leaking that value to like off-chain participants, it allows applications to capture and retain that value. So the main motivation of this talk is just there's many emerging options for application-specific sequencing, but I think it's a newer programming paradigm and it's not fully yet understood by developers. And we're lacking a framework to help developers evaluate the different properties of application-specific sequencing infrastructure. So the main goal of this talk is just to go over the current like application-specific sequencing landscape, so developers aware of the options if they're trying to write new apps, and also to like introduce a framework to evaluate these like different application-specific sequencing infrastructures under just as a communication tool to with users and developers. And a lot of this like sorry, there's like a lag with my slides sometimes. A lot of this like thought was like based on LTB, which I think is a great framework for evaluating the different like risks and just like infrastructure trade-offs that rollups make. So like the goal of this presentation is to start on a framework that we developers can use to like evaluate like application-specific sequencing infrastructures under. So the agenda of this talk is we're going to do a quick refresher over blockchain infrastructure, just so we have a common starting point. We're going to define some qualities that we care about for A2S infrastructures. And then we're going to apply these qualities that we define to existing and soon to exist and possibly theoretical infrastructure options, just so we can like get used to evaluating different options. Cool. So just to put out there, just in case people are like newer to application-specific sequencing, sequencing impacts an application because applications typically have state that represent like value ownership, and who gets to touch those pieces of state first in the block typically determines like how the value flows within the application. So it just like it matters for money. Examples of this is like the first swap in an AMM that typically is the swap that is able to capture the CEX-DEX like arbitrage value. So it's typically worth a lot of money to be first in the block. The first transaction after an Oracle update is able to then like go to the different dependent DeFi protocols to possibly do like liquidations or be the first to respond to the updated price. In general, just like how users are sequenced over an application matters for like how that application decides to maximize like certain user welfare. For example, for a borrowing like application, if they sequence liquidity ads before liquidations, that could like be a way for like that application to maximize the welfare for the borrowers instead of maximizing the welfare for the liquidators. So it's just a way that like applications can like define how they would like value to flow through their application. And we're going to be like looking at different infrastructures today and just really like noticing that like different infrastructures enable application specific sequencing in different manners. So just a quick, I guess, like overview of how crypto applications typically work. Normally, like a crypto application has a state root that is made up of like different pieces of state. And these different pieces of state typically represent value and who owns what value inside of that application. And there's code that will like run state transition functions over the different pieces of state. And typically, the code that is ran is determined by the different transactions and the order of those transactions. Most blockchains, they have a different mechanisms of deciding how the blocks are constructed and the order of the transactions inside of that block. So specifically, when we're looking at sequencing, the two questions we want to ask is which transactions are included and what is their order. And we're going to look at different applications today, or like application-specific sequencing architectures today, and they all like change this like generic blockchain architecture in like different ways to like enable applications to sequence themselves. Cool. So back to the framework. Again, like I've only been thinking about this since like last October. So like this is probably like an incomplete framework. The goal of this presentation is just to have this starting framework that we can probably grow and expand upon as a community. So the different qualities that I picked out, the first one is like, who decides inclusion? Who decides what transactions are like included in the block? How many entities, do we trust them? Do we not trust them? Those are just like some basic questions. Then differently, instead of just who decides inclusion, who decides the ordering. And this is where like application specific sequencing, hopefully the apps are able to like define this order. And the ordering like has some different qualities also in terms of like is the ordering entity a part of the chain or are they like outside the chain? Those are just things to think about when we look at the architectures later on. For the composability of infrastructure, there's two main things we want to think about. We want to think about the ease of access to liquidity for the application. This is like typically like DeFi protocols, they measure their success in the TVL or the total volume that they have locked up. And it's easier for a DeFi application to get liquidity if they exist on a chain that already has liquidity. Like that's why so many like apps exist on Ethereum today. It's because there's so much money already on Ethereum. And the other main question about composability is like how many transactions would it take to move your funds from one application to like another application? And would that include like a bridge transaction? Because that just is going to introduce like higher latency. The next quality we care about is like how granular is the ordering. Back when I was showing the general like state architecture, normally like applications have like different pieces of state, and applications can either control like all of the state or just like parts of the state. And this is going to be important for applications that rely on off-chain entities to do their sequencing. Just for the scenario that these like off-chain entities like go offline, it would be great if like the normal block ordering process would allow like applications to have users be able to like withdraw their liquidity. And I'll go into like more detail later on that. The next quality that we should really care about is like spam protection. This is just a general question of how efficient is the blockchain space used. I guess like toy example I'd like to use to explain this is like, imagine that you have an auction for an NFT, like a non-divisible assets, there's only one winner. And let's say that you have like 100 people bidding in this auction. It's just like, what we don't want to happen is we don't want all 100 bids to land on chain, because like really only the first winning bid, we want that one on chain, but all the rest are just going to fail. So that's just going to like add congestion and like clog up the block space and probably like increase gas fees. Like if you guys like were around the Ethereum community, like before like PBS, when we like had the gas wars, it's just like, that's the scenario that we would like to like avoid. And the last quality we like really care about in while looking at like A2S infrastructures is just like, does this exist? Is it theoretical? Like, when will it exist? Because like a lot of the infrastructures we're going to be looking at today like don't exist yet, just because this is like just a newer space. And yeah, so next thing we're going to do is we're going to apply these qualities to 6, I guess, like different blockchain architectures. I guess real fast, are there any questions on these? I just gave y'all like a ton of like information. Cool. Okay. Yeah, feel free to like interrupt me if something's like unclear. I know I speak like really fast sometimes. Um, cool. So the first infrastructure we're going to look at is actually a platform that lacks any like application specific sequencing infrastructure like natively. We're going to look at vanilla Ethereum. And we're just going to be like looking at this for the sake of comparison point for our other like architectures. So for like every architecture we're going to go over, I'm going to show like a slide that is like a generalized example of how the blocks are produced. And for every architecture that we look at, we're going to be answering 2 questions. 1, how is the block being produced? And 2, where in the stack is the application able to express sequencing rules? So for like vanilla Ethereum, the single block builder that wins the PBS auction is typically the entity that is able to have complete ordering over the transactions in the block, both inclusion and ordering. The application is not able to express sequencing anywhere. So this is not what we want. This is kind of an anti-example, and probably why like Ethereum in my argument has so much like MEV value like leakage. So now we're going to run through the different qualities and apply it to its architecture. First, who decides inclusion? It's typically the winner of the PBS auction, and that's like a monopoly over the slots. They have total control over the slot, and they also get to decide the ordering. In terms of the composability, though, the composability of this is extremely high because like there's many applications on the same chain. A single transaction is actually able to touch every application that it wants to, given that it has enough gas to do so. So it's a highly composable system. In terms of the app ordering granularity, there's none because applications have no space to express sequencing preferences. In terms of spam protection, Ethereum does have spam protection today. The block builders, they typically like offer like as a service to searchers who are typically bidding for the opportunities on chain. They will offer revert protection, as in like, hey searcher, like if your transactions are going to revert, I'm not going to put that on chain. And this just like helps the rest of the users of Ethereum to not have to compete with the failed searcher transactions. It just like overall helps reduce spam and keeps the gas price low. And yeah, so Ethereum like exists today, as we all know. So again, this is just an example of a blockchain architecture that does not offer like application-specific sequencing infrastructure. And now we're going to look at 2 chains that do offer application-specific sequencing abilities to the applications. First, we're going to look at like a generic vanilla version of the like Cosmos SDK paired with a Comet BFT. Then we're going to look at Astria, just like 2 options of chains that like enable app-specific sequencing. So Cosmos SDK with a Comet BFT. The first question, how is the block inclusion structured? So typically a single proposer has, again, monopolistic control over the transactions in the block. As in one entity, again, gets to decide what transactions are included, but then baked into the overall, like, I guess, like architecture of the chain, the app expresses sequencing rules. So this is like pretty cool in the sense that like now our application is actually able to sequence themselves. And I want to say that this is just like the default out of the box way that like Cosmos works. There's many modifications you can make as like an app developer to this to like change, I guess, like the application of the framework, which we're about to do. This is just the default case. A lot of people on Twitter were like, no, it doesn't work that way. I'm like, if you are like not an advanced developer and you just do the base minimum, it probably does work this way. So like if you are like a more advanced Cosmos app, definitely like communicate to your users like how you are different than this, because quite possibly you are different. Sorry for all the caveats. Just people on Twitter were just like, no, just like it's kind of stressful. Yeah, so who decides inclusion? Typically it's the validator at Monopoly. I do have like a little asterisk here just because like through ABCI++ and vote extensions, it is possible to like write your application in a way where like If 2/3 of the validators say like include this transaction, you can have like forced inclusion of a transaction. So there are like some like almost like out of the box ways to like minimally modify the inclusion, but like typically it's just like one single proposer. And like the ordering, now this is like an app chain, so it does have like application specific sequencing abilities, which is awesome. The composability of this is actually pretty low because it's a single chain. So if you want to get like liquidity into the chain that's like outside and does not like actually like originate on this chain, you're probably gonna have to do like bridging. And bridging like is not only slow, but like when you bridge, you have to like evaluate like, okay, what are the security properties of the start chain and what are the security properties of the like destination chain? It's just like more overhead for the user in terms of like doing your own research in terms of security. In terms of the app ordering, total control. So this is like pretty nice. We like that. In terms of spam protection, there's none out of the box. And again, caveat on Twitter, people are like, "Oh, but this is so easy to add." I don't really know how it is easy to add. I think it's a pretty like unsolved problem. But I guess like you can design your app to like process transactions in a way where it's like they do handle spam. So again, default case, there's none though. And this does exist today. So if you want to go write a application specific app chain built in a Cosmos ecosystem, you can totally do that. Cool. So that was, yes.
Just wondering if why like regular spam protection ideas like, I don't know, fee mechanisms won't work, or are you referring to the fact that this doesn't exist out of the box in Cosmos SDK and app developer has to build it or choose it?
Can you use, what did you say again as an example?
Sorry. Yeah. I mean, just implementing some fee mechanism, like transaction fee mechanism, just to slap it on the problem and be sure that if there is contention and congestion, it will figure itself out. And if you have spams, it will create congestion and the fee goes up, like it stops the
Yeah.
spam.
Yeah. I guess like I have a pretty like intense definition of spam protection. Like
Got
if
it.
you're trying to like run an auction still, like you're trying to like auction off like one S, like an NFT, like all those bids are going to have to go on chain somehow. So if your chain experiences like a lot of like MEV in terms of like a lot of opportunities where only one winner takes all, that's going to like lead to like a lot of people bidding for the same opportunity and just like increasing the amount of like failed actions that exist on the chain.
Would you say it's fair to say that like spam protection while preserving censorship resistance is like non-trivial, or?
Yeah, I totally agree with that.
Got it.
Yeah, it's out of all the architectures we look at today, like none of them fully solve this. like at the end, we're gonna do a huge comparison against everything, and like there's a lot of red everywhere. This is still like a pretty like new space. But yeah, thank you for the question, the clarification. So I guess the next architecture that we're going to look at is Astria, which is its own chain that like natively supports sequencing architecture for its applications. I guess like disclaimer, I do work here. I try to like be unbiased in my research though, so I hope that I'm accountable. So in this like setup, many applications live on the same chain, but they have the chance to add their own sequencing rules before they ingest the transactions that are given to them by the proposer. In this architecture, like the first question, who is proposing the block or who includes the transactions, again, it's like a single entity that has like monopolistic control over this over the slot. And then the second question, the applications post block production have a chance to reorder the transactions given the rules that they would like to apply. So this is like similar to the app chain, but just with multiple, I guess, like applications on the same chain. Yeah, so the first box, who decides inclusion, it's mostly the validator monopoly again. We're also like using Cosmos, comment BFT. So we do have ABCI++, but we're not like leveraging it. Just as like, I guess a side note, the applications are able to define their ordering, which is nice. And in terms of composability, this is like higher than the app chain because all the applications, if you want to move liquidity between them, it's like you don't have to do a bridge. It's not as high as Ethereum because like most likely it's going to take multiple transactions to do so. In terms of app ordering, yeah, they're able to fully control their sequencing, which is great. Spam protection, Astria does not offer anything. maybe one day in the future we could, that'd be cool. And Astria is in testnet, it's not mainnet yet. So cool. So we just like looked at two chain architectures that do allow applications to sequence themselves. Now we're going to look at like ways that we can do application specific sequencing on Ethereum 2.0. Just because I know like Ethereum 2.0, that's like, at least I'm like mostly in the ETH community. So this is like where like a lot of brain power like goes to. And we're going to look at like two options. The first option we're going to look at is called execution abstraction. This is like, I think the term was coined by the Fastlane people with their like Atlas EVM. I may be wrong on that, but the idea about execution abstraction, it gets its name from account abstraction, is that for applications, the way that their transactions or their blocks are constructed is that they rely on the what's called the FAT-TX model, which is basically like there's one giant transaction that contains all of the user operations or like the user intents that they would like to be sequenced through the application. So like the main like takeaway is like who's like deciding like a inclusion? It's the solver network typically in execution abstraction. Like this is a more complicated framework, so I'm not going to like explain it in super depth. But basically, like instead of like relying on a block proposer, you are relying on an outside entity, in this case, the solver network, to do the ordering of the application. And then the application, when they ingest the giant transaction that's given to them by the solver network, they check to ensure that the ordering was done correctly. So this is a way that you can do like, I guess, like application specific sequencing on Ethereum today, which is like kind of nice. But there's some like weird security trade-offs that you're making in this like setup. So like for inclusion, you are relying on like a solver network, which may not be the most like, I guess, like transparent thing. Like a lot of these like off-chain solver networks are like just an RPC and it's pretty closed source. So that is like, I guess, a security trade-off of like, cool, like you're able to do application specific sequencing, but like the question is like, is a solver network doing censoring or other things? And typically, like, I don't know if any solver network has more than like 3 or 4 solvers like actually participating in the network. But the benefit of like using this off-chain network is that now like applications on Ethereum can do their own sequencing, which is like, again, pretty cool. In terms of the composability, it's you're most likely going to have to do multiple transactions in order to get your liquidity like out of the start application and into the next application. Just because like account abstraction, I'm not sure like how flexible the actual like EIP 712 messages that are being signed or the account abstraction transactions, how flexible those are in terms of like crossing between applications. And now when we talk about like app ordering state granularity, this is when I first like introduced like this I guess like category. Like I said that it's cool if there's like ways if the off-chain network goes offline that users can still like remove their liquidity. It's in this like setup, if you're using an application that's like relying on execution abstraction, it's good if you can like remove your funds just through the normal Ethereum block building process, and like you're not being forced to rely on the solver network existing or being nice, since they are like an off-chain entity that you can't totally trust. So that's what I'm saying, like partial control versus like total control. You want partial control when you don't want to fully trust the off-chain pieces that you can't control. In terms of spam protection, yeah, the solver network can do filtering, which is nice. And yeah, this does exist today. I think you can use like the Atlas EVM today. Maybe I'm like 90% sure that they're live. I know that other like applications are building their own solver networks to do this. Like I know that Astria Labs, they have a architecture that looks similar to this as well. Cool. Are there any, I see it. Is there a question? Yes.
Yeah. Can you go back a few slides to the Astria one and the one before that?
Yes.
Yeah, I guess yeah, this and also the last slide before this. I'm curious if you can maybe make it like a little bit more solid for me in my head. What does like this flow kind of look like? Like where do the app sequencing rules kick in, and how do they like handle ordering? Like is it something as simple as like if transactions are if transactions are presented in a way that's like out of order, then those transactions will just like fail, or like how would this sort of work?
Yeah, so I guess like if you're building like an application on Astria, like normally at some point it's you just get like a giant like block of transactions from the proposer that are specific to your application. And you have a chance to like reorder them as you would wish, as long as that ordering rule is like deterministic. So it's like the application like interface, it's called the execution API. It's like you're fed a block of transactions and then you reorder them as you would like to, and then you run them through your code to determine the state root for that block.
I see. So it's sort of like a two-step process of like you have like users submit transactions, proposer collects all of them, gives them to each of the apps, and the apps send back potentially a reordered list, and which the proposer checks for correctness.
So no, the proposer doesn't check for correctness. Normally, like the applications on top of Astria or like kind of like roll up nodes. So they like define their own like state root. Like the proposer itself doesn't like know of like the application state root at all.
Gotcha. Okay. Can you go back to the previous image as well?
Yes.
Yeah. So in Cosmos, is it like what does that look like? How does this flow look?
Yeah, so this is highly programmable because like I guess like it's an application chain, so there's a lot of wiggle room in the design process. But normally the proposer like creates a block of transactions, and then like that proposer might be forced to follow certain ordering rules to create like valid blocks that then other proposers would, or I guess like other validators would validate to make sure that they did it right. I think that's normally how it works.
Gotcha. This is specifically for AppChain. It's not like a generic Cosmos plug and play.
Correct. Yeah. Like for example, like for like Cosmos, like you could have a generic like EVM on this, and then like you're not going to have like application specific sequencing rules applied to that.
Yeah. Gotcha. That makes sense. Thank you.
Awesome. Cool. I like the questions. Thank y'all for asking questions. Okay. So yeah, now let's go back to, I guess, infrastructure on Ethereum. So this is like, again, this execution abstraction relies on a solver network and account abstraction. Sorry, I just saw a question. This is generic to ABCI++. Yeah. I guess like a quick side note, like, yeah, like Cosmos, I think normally it's like Cosmos SDK plus like comma BFT, which uses the ABCI++, I guess like a framework for their blockchains, which has like a lot of cool like sequencing stuff built in. Like you do begin block, like end block. You just have a lot of like space like programmer transactions. Okay, back to execution abstraction. Yeah, you have a solver network and an account abstraction. The other infrastructure I want to talk about for Ethereum 2.0 is something that I've been working on for a while. It's actually EIP 7727, which enables like application specific bundles on Ethereum. I used to play around with like builder specific bundles. And like, I just want to show you all this framework as like a comparison to the account abstraction like solver framework. So like in this setup, you would have like a TEE like off-chain with an application specific mempool that like applies the app ordering rules and constructs a bundle of transactions that then like when like ingested into the normal block Ethereum process cannot be broken apart. So like the application logic lives partly off-chain inside of like a TEE to do the ordering, and then like on-chain you would check to ensure that the TEE ordering was like correct. So this is just like a different way of doing, I guess, like application specific sequencing on Ethereum one day. This EIP is not live, it's still in draft, and it could take like up to like 2 years to get it included if like Ethereum does want to have this like included eventually. I just wanted to like include like this like example architecture as like another way to do like Ethereum specific sequencing besides like relying on account abstraction. In terms of evaluating this architecture, inclusion is typically ordered by an off-chain entity. I like to use CVEs for this. but those have their own like security trade-offs. The ordering is like defined by the app, which is like the whole goal of application-specific sequencing. But the composability, again, is like medium. Like you're probably gonna have to use multiple transactions to hop between applications. Again, this is super similar to the previous architecture where the apps have total control, but you probably want to have like the withdrawal paths sequenced by the normal block process just for safety. And then in terms of spam protection, TEs can filter this nicely. I really do like TEs for this use case, specifically like mempools that do like spam filtering. And then, yeah, so this does not exist today. It is in draft form. Yeah, so there's a question in the chat about like why we need an EIP for this. I was like doing this architecture just with like builder bundles, and it was like extremely difficult to find the winning builder and have them include these transactions in their blocks. Just in the case that like not all builders like run, sorry, not all blocks on Ethereum. I think only 90% run MEV boost. And then also just like finding the winning builder is hard. I was like doing this on like testnet, and the only way I can like have my bundles land successfully is by like paying like an enormously high like I guess like gas tips to like have like to force like the block builder that I was like sending my transactions to always win the block building competition. I guess like with this EIP, you don't have to like pay like a ton of gas. Okay, so we need in protocol support for bundles. Yeah, this is what like this EIP like enables. There's another question. It can't be permissionless if you don't have on-chain checks. Could you expand on that question? Oh, nice. Sorry. Okay. Nice. Okay. Are there any more questions on bundles? Nice. This doesn't exist today. If you would like to exist, please let me know. I'd love more help on this. Cool. The last architecture I want to show you guys is a pretty hot topic right now, at least at SBC, is multiple concurrent proposers, which is a way to upgrade Ethereum to like natively support application-specific sequencing. And this is like mostly being led by Max Resnick. That's why like I've been using his picture like all over the slides, but also his like I guess like co-thinker Malesh Pai. And yeah, so MCP is multiple concurrent proposers, which is actually a really cool like idea. Whereas like instead of having like a single proposer like including transactions per block, you have multiple proposers working together to like have a giant set of transactions. And then like then there's a global block ordering rule that applications are aware of to use to program their own applications in a way that like can control their own sequencing. So this is like a super cool architecture idea that I like, but I think there are some like extreme caveats that have not been fully like explored or answered. So for like a multiple concurrent proposers, you have multiple proposers, including transactions. So this is like, this solves for like censorship resistance, which then enables like a block ordering rule to work. Because like if you like actually don't have like total censorship resistance, the block ordering rule then really doesn't do anything, and you're back at like Ethereum like 2.0 in the sense that like a censoring like a proposer knows the block ordering rules and then can like interact with applications as if the application specific sequencing rules did not exist. So it just like you need the censorship resistance piece to be like rock solid for this to work. In terms of composability, depending on how the block ordering rules are like implemented, it is possible that the signal that you use to express ordering to the application could be like conflicting between applications, meaning that like, again, you might need multiple transactions to hop between applications. In terms of the state granularity, I guess in this one, apps have total control. I guess you don't really need the partial controlled part because like the block ordering rule is like actually just like the normal default way. So I guess that's pretty cool. In terms of spam protection, we actually lose spam protection on Ethereum through this process because no longer can proposers filter the failing searcher bids in this like setup. which would like lead to like lower block chain like efficiency again. This is like my like largest critique of MCP. It just like I feel like it's like kind of a regression in some regards in terms of just like overall usability of like Ethereum. And then also like in terms of existence, this is still a pretty new idea. It's kind of like theoretical still. Like they're working on like a consensus plan. I think it's called Braid right now is the one that they're considering, but there's like some like actual problems with it that are like unsolved. And they also have not specified a block ordering rule. And like we would have to like do research on the block ordering rule to make sure that it can resolve like, what if you have two transactions that have the same priority? Like which one goes first? Because you can't really do like time first seen because multiple proposers like who sees what transaction first is kind of hard to like determine. So they're just like open-ended questions that might make this more of a theoretical thing and not a thing that's going to exist. But if they do solve those things, it could exist maybe like 2, 3, 4 years. It's going to be like a giant like Ethereum upgrade if Ethereum goes down this path. So like I think it's great from a theoretical level, but like practical, like if you're like an app developer who wanting to do stuff in the next like year to 2 years, like I'm not sure if it's like a viable option. Yeah, so putting it all together, we looked at 6 different architectures. Yes, Mohammed.
Yeah, I was wondering like how this multiple concurrent proposer can help app developers specify their like ordering rules, because my understanding is like this block ordering rule is something that's fixed in protocol, and if I build an application the day after it's fixed, it probably like cannot change to accommodate me. So where does my application specific ordering kick in this process?
Yeah, so great question. I think there's like 2 main ideas of like a block ordering rule that is like programmable from the application layer. One is called Priority is All You Need by like Dan Robinson at Paradigm. The idea is that like when you submit a transaction, you can like also signal like how much money you're like willing to pay to have that transaction placed in a certain part of the block. So that's like normally how like EIP like 1559 like default block building works. It puts the higher price transactions first. So like, but if this is enforced on like a global like block level, this like kind of forces like applications to be able to be sequenced a certain way. Like let's say that like I am an application and I want to sell the NFT to the highest bidder. Like the person who like pays the most in that like fee signal will go first. So they're able to like win the auction, express the auction that way. Then also like if you want to have like liquidations happen after like liquidity ads, you would say like, hey, everyone who wants to do like a liquidity ad, use value 5. And everyone who wants to do like a liquidation, use value 4. And if you don't use those values in your transaction to have it like actually sequenced in a certain order, then your transaction is like invalid. So there's like ways to like use like the awareness of like, if I have this transaction with this like fee value, it's going to be in the block, put into the block in this way in relation to the other fee values.
Got it.
I guess like, yeah, I guess like the other idea that Max Resnick has been working on is called like execution flags, which would be bringing like similar to like ABCI++, like begin block, end block functionality to Ethereum by having like apps signal how they would like, no, sorry, having apps signal what flag that they use, and then like also transactions signal that they're a part of that flag group. It's still super theoretical, like not super worked out, but like if it could be worked out, that'd be really cool. Another question, assuming that block ordering rule is expressive enough, we can encode our application sequencing rules within it. Yes, yeah, that's the general idea. And that's, yeah. Cool. So I guess we looked at 6 different like architectures, and like when we like look at them all together, as you can see, nothing's fully green. Like this space is still like pretty, I guess like it needs more thought put into it. We're doing our best. I love that we have options today. Like you could like use Astria on testnet. You can build your own app chain today. You could do like execution abstraction today. So there are ways for application developers today to use application specific sequencing with the known, I guess, like trade-offs. Yeah, so I guess in conclusion, there's many emerging options for application-specific sequencing, and I encourage developers to ask these questions when they're evaluating in the infrastructure, and for users of apps to also like ask these questions, just to make sure that they're not going to be like rugged when the T or like solver chain goes off chain or just like misbehaves. Always do your own research. And yeah, my name is Lily. Find me on Twitter or email. Any more questions? Yes.
Yeah, I have a question. Thanks for a great talk. I was curious about the notion of composability. So the only architecture that you mentioned as high composability is Ethereum. And to me, this means, high composability is one transaction. Throughout the execution of one transaction, it can interact with multiple dApps. And none of the other architectures offer this. Do you think there's like an inherent conflict between composability and specific sequencing?
I do. Like, this research is pretty early, but like it's hard to see like if one app is like, I want to be sequenced a certain way, and another app is like, I want to be sequenced a certain way. Like, I guess there's ways where you can like mesh the sequencing of the applications to allow one transaction to flow through like many apps. But for example, the part is all you need paper. Like, if you use value 5 in one application, that value 5 might mean a very different thing in like another application. And the way that they're like looking at like implementing like execution flags, like literally like groups transactions of the same flag together and doesn't have them like mixed in any way. So just like today, yeah, I do think there's a conflict between composability and app specific sequencing. Yes, Mohammed.
I just want to check whether my understanding is correct. To me, it feels like these app-specific sequencing rules turn apps to separate or almost separate execution domains or like sequencing domains. The same thing we have for rollups, and like to solve this problem of like making this apps with app-specific sequencing rule composable is almost the same as solve for rollups to have like composable like execution or something like that. Maybe
Yeah.
it's a bit simpler here, but like very similar looking.
Yeah, like I totally. It's like it's the same problem, just like on a different venue. Like instead of like hopping between rollups and like interacting with a base L1, now you're just like hopping between like different state roots of the applications on the same chain. But like similar problem of just like, what's the latency of this? But instead of like doing a bridge hop or like I guess I forgot what they're called for like solver and rollups when you go up and down between the chain layers. But like similar motions.
I guess I am surprised that the on the spam protection like category there haven't been well, I guess I'm curious if there are like other ways of like dealing with this, because I feel like there should be ways of like penalizing propagation of spam or something like that. Maybe it's like you like wrap transactions in like meta transactions, wrap meta transactions within transactions, and each transaction is like a submission or something. Like I'm surprised some of these more out there like EIPs haven't thought of something like that, or maybe that doesn't work. I'm curious what you think.
Yeah, I think it's like a trade-off between like censorship and spam, just because like if you don't have like censorship solves, then wait, I'm saying that wrong. Like the problem is that like if you like, I don't know how to say this. Yeah, because like if you can censor someone's bid, then you're effectively, you could just like win the auction yourself. That's why like block builders make so much money. I think it's just like a weird trade-off. It'd be great if like we like had a way of like having like invalid transactions on Ethereum. Like right now, like if your transaction like reverts, that's like 21,000 gas. And maybe for like reverting transactions, we can like actually have that lowered to be like 1,000 gas instead of like 21,000. It just like depends on like what's the cost of like including the like reverting transactions on chain or not. I know that Dan Robinson really wants like reverts made cheaper to make like his priorities all you need, I guess, like constructs like more feasible. So it's like definitely an open area of research.
I guess I mean like in Ethereum right now, PBS filters for like transactions that fail because there's no incentive for builders to include those in the blocks.
Oh no, that's not it. Searchers are bidding to the block builders. Like builders offer this as a service to get searcher order flow to make their blocks more valuable. Like normally builders actually want to include those transactions if they could, because like it would increase the overall value of the block.
Yeah. Sorry, I see. So this is on like the proposer searcher then? Sorry, the builder
Yeah.
searcher.
Yes, because like if you're a searcher like competing for an opportunity, you don't want to be paying the 21,000 gas to have your transaction just fail like immediately. You would rather like have it filtered out beforehand. So yeah, it's the service that the builders offer just to gain more order flow.
And sorry, like the assumption there is like builders do this in order to build up like good reputation. Like if they screw around with this and like include failed transactions, like people will submit to them like less or trust them less, right?
Yeah, definitely. It's a reputation based.
So like I guess is there not something similar on like the censorship is still like I guess kind of a risk, but like I guess basically like you know, compelling or like encouraging whoever's submitting in some of these like fancier EIPs not to like submit bids that are gonna like fail or like not win anything valuable. I don't know, maybe I'm thinking about this wrong, but I guess I'm surprised that spam protection is like it seems like no one can do anything about this.
Yeah, like I think like endophysics comment is like you don't know it's spam until like you compare it against like everyone else's bids. It's like it's hard to know like who the actual winner is without like looking at everything. Like I really like TEs for this, but like TEs like have their own problems. Like it's like having a network of TEs is like security wise like impossible if you actually want to keep the information like hidden long term. There's just like all these like very you can do like replay attacks, like side channel attacks. Like if you can't control like who's running the TE, it's like all it's like off chain stuff just comes with a ton of like trust assumptions.
I feel like
I guess
for
like the oh, sorry, go ahead.
so just one other question or comment on the spam topic. I feel like unless we're talking about app chains, apps don't really have much incentive to reduce spam because it's more like a problem for the chain and not the app. Like if the highest bidder wins, I don't care if the other bids are submitted or not to the chain as an app developer.
Yeah, but I guess as like an application user, it's better if like you don't have to pay for your transactions that are just going to fail. Like for like conservation of like funds, if it's like an expensive chain.
Yeah.
I like you guys. You guys ask good questions. Ooh. Thank you guys for being a part of this. I appreciate y'all's input.
Perfect. Thanks everyone for joining. Thanks Lily for the great talk.
Thanks, Lily.
I think
See you guys next time.
see you all next week. Take care.